Are you ready to transcend the flat, two-dimensional screens that have defined our digital lives for decades? Imagine a web where you don't just look at content, but step into it, interacting with digital worlds as if they were physically present. This isn't science fiction. It's the ambitious vision of the holographic internet, poised to redefine our online experience. The holographic internet aims to fundamentally transform how we perceive and interact with digital information. It moves beyond traditional 2D screens, replacing them with truly immersive, three-dimensional holographic browsing experiences. This emerging paradigm leverages advanced 3D graphical techniques to produce dynamic digital holograms directly within web environments. Think of it as creating virtual 360-degree worlds that are fully accessible through your standard web browser. This isn't just about viewing 3D models, it's about constructing entire volumetric spaces that users can explore, manipulate, and inhabit. The goal is to blur the lines between the digital and physical, offering an unprecedented level of immersion. The holographic internet is envisioned as a revolutionary new media platform, fundamentally different from anything we've experienced before. It promises interactive, holographic 4D web pages that are not merely viewed, but experienced. This means moving beyond static images and videos to dynamic, living digital environments. The core concept involves creating vivid, volumetric imagery that closely resembles real, light-based holograms. These aren't just flat projections. They are designed to occupy space, allowing users to perceive depth and dimension naturally. The ultimate aim is to transport users directly into these virtual environments, making them feel truly present within the digital realm. This shift from 2D to 3D, 4D interaction opens up entirely new possibilities for content creation and consumption. Imagine navigating a website not by clicking links, but by walking through a virtual museum, picking up artifacts and examining them from every angle. The internet becomes a navigable, explorable space rather than a collection of flat pages. Achieving this level of immersion requires a sophisticated technological stack, pushing the boundaries of web development. Holographic web design heavily relies on cutting-edge 3D technologies, with WebXR at its forefront. WebXR is a powerful API that enables immersive experiences directly in the browser, bridging the gap between the web and virtual, augmented reality. It leverages modern web standards like WebGL and the emerging WebGPU to generate complex, three-dimensional computer graphics. These APIs allow developers to tap into the raw power of a device's graphics processing unit, GPU, enabling high-fidelity rendering. The challenge lies in simulating the physical properties of light, including intricate lighting, shadowing, and reflection calculations to create convincing holographic effects. Frameworks and libraries such as Three.js and Babylon.js are instrumental in abstracting away much of this complexity. They provide developers with tools to easily create and manipulate 3D scenes, objects, and animations within a web browser. For more complex game engine-like experiences, platforms like Unity and Unreal Engine can export content directly to WebGL, making their powerful rendering capabilities accessible on the web. These tools handle the computationally intensive tasks of rendering volumetric data, ensuring that the digital holograms appear realistic and responsive. The goal is to achieve this without requiring specialized viewing devices for basic interaction, making the experience as seamless as possible for a broad audience. This involves clever optimization techniques to deliver rich 3D content efficiently over the internet. The concept of holographic media is central to this new internet paradigm. Unlike traditional 2D media, Holographic media encodes numerous perspectives into a single image or video. This allows for the representation of true 3D content, where depth and spatial relationships are inherent to the data itself rather than being simulated through perspective tricks. This advanced encoding means that the same 3D content can be displayed across a wide range of platforms, from conventional 2D screens that render a specific perspective to true holographic displays that project light fields. This versatility is crucial for widespread adoption, ensuring that 3D creators can share their work to a broad audience regardless of their viewing hardware. Technologies like light field capture and volumetric video are key enablers here. Light fields capture the direction and intensity of light rays from every point in space, allowing for dynamic rendering of scenes from any viewpoint. Volumetric video captures real-world performances in 3D, creating digital doubles that can be placed and interacted with in virtual environments. The development of standardized formats for holographic media, such as GLTF, GL transmission format, and USDZ, Universal Scene Description ZIP, is vital. These formats facilitate the efficient transmission and rendering of 3D assets across different applications and devices. This ensures interoperability and fosters a rich ecosystem of 3D content. A core tenet of the holographic internet is universal accessibility. The vision is to make these immersive holographic experiences available on a diverse array of devices, ensuring broad reach and adoption. This includes traditional desktops, mobile devices, dedicated VR/AR headsets, and even emerging true holographic displays. The beauty of a web-based approach is its inherent platform independence. A single holographic web page built with WebXR can theoretically adapt its presentation based on the user's device. On a desktop, it might render a navigable 3D scene. On a mobile phone, it could offer an AR overlay, and on a VR headset, it would provide full immersion. This device agnosticism is crucial for mass market appeal. Users won't need to purchase expensive, specialized hardware just to access a holographic website. Their existing browsers will serve as the gateway, dynamically adjusting the experience to their capabilities. This lowers the barrier to entry significantly, fostering widespread adoption. While true holographic displays are still nascent, devices like the Looking Glass Go offer a tantalizing glimpse into this future. These devices present 3D images without the need for cumbersome glasses or headgear, creating a genuine sense of depth and presence. As these technologies mature and become more affordable, they will unlock the full potential of the holographic internet, delivering truly glasses-free volumetric experiences. The potential applications of the holographic internet are vast and transformative, extending far beyond traditional web browsing. In education, it could revolutionize learning. Imagine medical students visualizing and assembling the intricate parts of a human heart as a touchable hologram, rotating it, dissecting it, and understanding its complex structure in a way that 2D diagrams simply cannot convey. In engineering, designers could collaboratively inspect and modify 3D models of complex machinery in real time from different geographical locations, as if they were in the same room. This fosters unprecedented levels of collaboration and understanding. The ability to interact with digital objects as if they were physical opens up new paradigms for design, prototyping, and training. The collaborative potential is particularly exciting. Holographic environments could enable multiple users to interact within the same shared digital space without the need for individual VR headsets. This makes them incredibly useful in public spaces like museums, where visitors could collectively explore ancient artifacts as interactive holograms, or in architectural firms where clients could walk through a proposed building design. Beyond these, consider retail, where customers could virtually try on clothes as holographic projections, or explore products in a fully interactive 3D showroom. In entertainment, concerts could feature holographic performers, and games could break free from screens, projecting interactive elements into your living room. The possibilities are limited only by our imagination. Despite its immense promise, the path to a fully realized holographic internet is fraught with significant challenges. One of the most pressing is the sheer data intensity of holographic communication. Representing and transmitting volumetric data requires orders of magnitude more bandwidth and processing power than traditional 2D content. This necessitates the development of new, highly efficient compression techniques and advanced processing algorithms for mass-market solutions. Streaming high-fidelity holographic content in real time to millions of users will require robust network infrastructure and powerful edge computing capabilities. The current internet, while fast, is not yet optimized for this scale of volumetric data. Widespread adoption also hinges on addressing challenges related to hardware and software support. While WebXR provides a foundation, the ecosystem of compatible devices, development tools, and content creation pipelines needs to mature significantly. The cost of developing high-quality holographic experiences can be substantial, requiring specialized skills and resources. Furthermore, ensuring accessibility for all users, including those with disabilities, will be crucial. Designing intuitive interaction methods for 3D spaces that work across diverse input devices is a complex task. Overcoming these technical, economic, and usability hurdles will be key to unlocking the true potential of the holographic internet and making it a ubiquitous reality. While true holograms, as seen in science fiction, use lasers to encode and reconstruct light fields, the holographic internet, as we discuss it today, primarily refers to virtual holograms. These computationally simulate the effect of depth and presence on various displays, from 2D screens to specialized volumetric displays. The distinction is important for tech enthusiasts. We're building a simulated holographic experience that feels incredibly real. Devices like the Looking Glass Go are pioneering this space, offering a tangible glimpse into a future where 3D images are presented without the need for glasses or headgear. These light field displays are a crucial step towards making volumetric content truly accessible and intuitive. As display technology advances and as web standards continue to evolve, the line between simulated and true holography will blur further. The journey to a fully immersive holographic internet is an exciting one, promising to transform our digital interactions from passive viewing to active participation. It's a future where the internet isn't just a window to information, but a world you can step into. The holographic internet is not just a concept, it's a rapidly evolving field. Dive deeper into WebXR development, experiment with 3.js, or explore the capabilities of light field displays. Share your thoughts in the comments below. What holographic application excites you the most? Don't forget to like this video and subscribe for more insights into the cutting edge of technology.